For part 3 of the Coin Vault in Fusion 360, we're going to take our individual components and assemble them digitally in a model workspace with McMaster Carr components and also the modeled rivet. So in our file, we're first going to find our bottom piece, and over here in our browser, find the bottom, should be highlighted. We're going to right click and ground that component. That will lock this component physically in space, but you can see we can still move all of the other components around. We're going to use this joint tool, keyboard shortcut J, to position components relative to one another and define the relative motion. There isn't any motion relationships with this assembly. So component 1 is the first component is the one that's actually going to move. So this component, and we're going to zoom in and we're going to select this edge right here. It's the bottom edge right in the middle, and that's going to be mated with this top edge right in the middle. And then what we need to do is see how that edge is now sharing between the two components. We need to rotate this 90 degrees and click OK. And we now have our joint, so we have a spot where we can weld. This edge is not going to be flush with anything. We're just mating along the edge of the part, not the surface. So the surfaces are not flush. And that process is basically repeated. Joint, going to select the midpoint on this bottom edge with the midpoint of this top edge, and then typically we're going to have to rotate it 90 degrees. We get everything lining up. Repeat. Joint. Sometimes you can flip it. This one needs to be rotated quite a bit. So that's going to be rotated this way. You can also move it, but this is a little more work. I'm going to cancel that. I'm going to start over. Maybe I accidentally clicked on something. So joint. When you get this edge, that edge, there we go. So that worked a little more how I wanted it to. And then rotate that in negative 90 degrees. Okay. Got one more side. I'm going to do that edge right there to that edge right there, rotated 90 degrees. Our top is going to be right there to right there, and we shouldn't have to rotate this one, but let's look and see. Should have a gap there, so I'm going to flip that around and rotate it. Looks like I got the wrong edge on that one. So we'll try that again. Joint. Maybe the third try is a charm. Let me slow down really. Joint. That edge. Oh, there we go. I think I was selecting this edge right here, not this one. Click OK. I'm going to go back to my home isometric view. The bottom one, joint. We're going to actually joint through the circles there and there. Is that the right one? Oh, I picked the wrong hole. So we want that one. Once again, I'm getting a little sloppy with my selection, so slow down. There we go. Click OK. Joint. Going to pick, there really isn't a top or a bottom for this part since it's symmetrical, but I'm going to go ahead and pick the underside right there. That's going to get jointed with the top of right here. Notice this top hole is a little bit bigger. That's because we can water jet this to the exact size, but with the plasma cutter we can't plasma cut to the exact size because of our tolerances with our machine. We're going to use a drill to upsize that hole. And our final piece is going to be our acrylic joint. That hole, I'm going to go in here and then I'm going to get this edge right there. That looks good. Click OK. Save. Only thing that doesn't look good, this top piece, we should have, this should not be flush on the top. So this top piece, I go up here, the joints, looks like it's going to be this joint right here. You can edit that joint. Oh, there's our problem. It's the back piece. So this joint right here is incorrect. So it's rigid 4, edit joint. There we go. There we go. Now we got all our proper edge joints where nothing is flush. Go ahead and save. And we're going to go up here in our data panel, and then we're going to take this rivet that we made, right click, insert into current design. I'm going to move it over here. Click OK. And we need 1, 2, 3, 4, 5, 6 of those. Notice it has a little link next to it. That means if we change our original rivet, it will change what's in our model. And we don't really need that for this assignment, so we're going to go ahead and break that link because we know that we already created this rivet correctly. It's not the ideal length of rivet for this project, but it's what we have on hand, and it's also in the anodized coating matches the brass plate a little bit better, so it's kind of more for looks. So we're going to take this rivet and we're going to copy it and paste it, and then I'm just going to move it down each time I paste it, or at least just make sure it's not stacking on top of each other. And rivet 6. And to install the rivets, we're going to go, let me close this, joint, we're going to get this section right here, and that's simply going to go right there. Click OK, right click, repeat, there, and there. Sometimes if your rivet gets installed upside down, you simply just need to click on the flip button and that will flip it around. Okay, we got all the rivets. The next thing we'll need to do is install our nuts and bolts to mount the bottom plate on. I'm going to go ahead and save that. I'm going to go into Insert, McMaster Carr Component. And in here we want to go to Nuts, Hex Nuts. This is going to be a low strength steel hex nut, and we want a quarter 20. Looks like we can get 100 of them for $2.89. We're going to click on our McMaster Carr part number. Going to go to product detail, and then in here we want to change this to a step file and click save. And that inserts our 3D modeled nut. Unfortunately, McMaster Carr did not have the 3D model of our rivet that we needed, so we needed to create that from scratch, but fortunately they do have the nut. And they also have the bolt. Insert McMaster Carr component. We're going to go to screws and bolts. We're going to go down to hex head screws. Hex head screws, steel hex head screws, and then not a, let's see, low strength is going to be probably right down here, low strength steel. We can also do a filter search right here, quarter 20, and we're going to do a quarter 20 half-inch length. So I click on that one, product detail, there's our little stubby quarter-inch bolt, and then insert that as a 3D step file. Move that over so it's not getting inserted into the middle. And now we're going to make copies of these components. I can rename this one. I'm going to keep the McMaster Carr part number. That's handy if you have to order it. And I'm going to call that nut. And I'm going to call this one bolt. And then we need to make copies. Copy. Paste, capture position. I'm going to drag this one down, paste. So we got 4 nuts, and then we need to copy our bolts. Go ahead and save that, and now we need to install that hardware. We could turn off some of our objects with the visibility, so we don't need to look at the sides, we don't need to look at the bottom. Actually, we need the bottom. We don't need the coin slot or the window or the sides or the top or the front. And now we can take, we don't even need all the rivets, but I'm not going to take my time to uncheck all those. So we're going to go joint. We're going to put this nut, and sometimes you can't really get the center point. What you need to do is kind of pause, and I can see the center point right there. Hold down control, and that kind of freezes everything, and then you can go and click on this coin. So that coin's going to go right there. And notice this is where my nut's on the wrong side, so I'm going to flip that. There we go. Because we're just going to tack weld here and here to tack weld this nut into place. Right click, repeat the joint once again. Hold down control so you can select that center point. Right there. Looks like we got to flip that one also. Right click, repeat. Hold down control. There. Flip. Okay. And then our last one. And our bolts, basically the same process. Make sure you're actually getting that center point. Flip. That's how bolts work with nuts. Turn everything back on with its visibility. Nice. I don't need to see all these joints on there, so I'm going to turn off the light bulb. I'm not deleting my joints, I'm just changing the visibility. Go ahead and save. Another cool thing to do is go into inspect, and it's called a section analysis. And I'm going to click on this surface and drag this arrow. Basically, it kind of gives you a little section view of your model. So if you want to see inside of something or kind of see how much screws sticking out, don't really need that. And then the final step will be appearance. We're going to go into here and make our model a little bit nicer as far as how it looks. Plastics, transparent. We're going to go polycarbonate clear. We're going to drag that right on that surface. That makes that clear. Once again, we need to close that. We're going to go to our metal, and we're going to go, this black oxide is going to be close enough. Let's see what that looks like. It's a little dark for what we're doing. Don't want that. If we go into steel, maybe this steel satin, that's closer to what we're actually going to be using. So we're just going to drag these. You can also drag from here onto my components. These screws, bolts might be galvanized. And let me turn off my window and side. The nuts are just going to be a plain ungalvanized steel. Notice it changed all four of them because they're linked together, they're copied versions. And one more time, appearance, we're going to go back into here and brass, polished for that plate. Click close. So that is the 3D assembly with appearance textures for the Coing Vault.